Hello and welcome to lesson 2i. I can prove angle pair relationships theorems and their converses. So just a quick reminder, guys, whenever we're looking at theorems, we're going to be grading you on the geometric proofs rubric, where you need to be paying attention to your structure, how your reasonings, are you making sensible steps, and your mechanics. Do your statements and reasons work together? So let's take a look at some examples here, guys. The first thing we're going to prove today is the alternate interior angles theorem. And the alternate interior angles theorem states that if two lines and a transversal form congruent alternate interior angles, then two lines are parallel. Now, if you remember from our introduction to geometric proofs, the given is always in our hypothesis statement. If two lines in a transversal form congruent alternate interior angles. So I'm going to pick a pair of congruent alternate interior angles to be my angles for this problem. And I'm liking angle 3 and angle 6 as some alternate interior angles. So my given is that angle 3 is congruent to angle 6. And then my conclusion statement, the two lines are parallel, that's my proof statement. So I want to prove that K is parallel to L. That's my goal here. So we're going to prove the alternate interior angles theorem. Now the key to proving these is to find a buddy angle. And a good buddy angle is an angle that is corresponding in one way to one of your given angles and then has another good relationship with the other angle. I'm liking angle 8 as a buddy angle because it corresponds with 3 and it's vertical with 6. So we're going to have two really nice congruence relationships whenever we're talking about proof here with angle 8. So let's dive into our proof. We always start off with our statements and reasons. Okay. And we list our givens. My given is that angle 3 is congruent to angle 6. My goal is to prove that K is parallel to L. Well, at this moment in time, you only have one tool in your toolbox to do this. And that tool is the corresponding angles postulate. It's the only thing you know right now that will allow you to prove that K is parallel to L. So if you are able to prove, you want to show that two corresponding angles are congruent. If you can do that, then you've proven that the lines are parallel. Well, that's where buddy angle 8 is going to come in, okay? I will be able to show that 8 and 6 are congruent, right? Oh, by the way, my first given here, that's a given, right? I can say that angle 6 is congruent to angle 8 by the vertical angles theorem. Yeah. And then we've now proven 3 is congruent to 6 and 6 is congruent to 8. Well, that means by transitive property, I can say that angle 3 is congruent to angle 8 by my transitive property of congruence. Well, we just said if we're able to prove 3 congruent to 8, well, 3 and 8 are corresponding angles, and if corresponding angles are congruent, then by the corresponding angle postulate, I can say that K is parallel to L. So I've got my congruent corresponding angles. I can now say that K is parallel to L by the corresponding angle postulate. And we've done it, guys. We've proven the lines parallel. Okay, so we just proved that if you have a pair of congruent alternate interior angles, that their boundary lines are parallel. So let's go on and look at another example of the converse of the corresponding angles postulate. So the converse is really similar, except now we're starting with the given that we have two parallel lines. So my given is that K is parallel to L. And what I want to show is that if I'm given two parallel lines, then my alternate interior angles are congruent. So in this case now, I want to show that 3 and 6 are congruent. Angle 3 is congruent to angle 6, okay? Now, again, the only way you have to prove angles congruent, you know about vertical angles. You know about linear pairs, but they're not congruent. And you know also about the converse of the corresponding angles postulate. Converse of the corresponding angles postulate. And it says that if two lines are parallel, then corresponding angles are congruent. Well, 3 and 6 are not corresponding angles, but coming back to buddy angle 8 does correspond with angle 3, and angle 8 is congruent to angle 6. So I can use angle 8 again to be the pin around which I can swing this whole proof. So I'm now going to take a look and see how I can do this. So my first step is K is parallel to L, and that's given. And now I want to spend my next 2 steps describing how both of those given angles that I'm trying to prove congruent, I want to show how they relate to angle 8. So I can say that angle 3 is congruent to angle 8 by the converse of the corresponding angle postulate. Okay. And I can also say that angle 6 is congruent to angle 8 by the vertical angles theorem. Well, now we've just set ourselves up. Again, we love it when I'm able to say that 2 angles are congruent to the same angle, because when that happens, I'm now able to say those angles are congruent to each other. I can now say that angle 3 is congruent to angle 6 by the transitive property. Property of congruence. Well, guys, that's what I was trying to prove. I did it. I'm done with my proof. Not too bad. So let's take a look at kind of how this all falls out whenever we're actually talking about throwing values into all of this. So now I'm given that K is parallel to L, and I want to prove that, and that angle 1 is 25 degrees. And I want to prove that angle 7 is also 25 degrees. Again, with something like this, I'm going to want a buddy angle, and a good buddy angle will be corresponding to one angle and then have some kind of relationship with the other angle. Good buddy angles in this problem, I like angle 4 a whole lot because it corresponds with 7, and I like angle 1 because it corresponds with 7 and it's vertical with angle 1. So let's go ahead now and get started on this proof since we've chosen our special helper angle. I'm going to start off by writing, again, statement and reason, just like I always do. Statement and reason. And I'm going to list my givens. K parallel to L, and measure of angle 1 equal 25 degrees, and given. Okay. Now, my next 2 steps need to be describing how angle 1 and angle 7 relate to angle 4. Well, the first off, I can say that angle 1 is congruent to angle 4 by the vertical angles theorem. And I can also say, because they've given me some parallel lines, I can say that angle 4 is congruent to angle 7 by the converse of the corresponding angles postulate. That's our favorite thing right now, right? Corresponding angles postulate and its converse. Well, if I know that, I've got 1 is congruent to 4 and 4 is congruent to 7. Therefore, I can say that angle 1 is congruent to angle 7 by the transitive property. Transitive property of congruence. And if they're congruent to each other, guys, we have to make a conversion between congruency and equality at some point because we've got this business going on. My next step has to be saying that the measure of angle 1 equals the measure of angle 7, okay, by the definition of congruent, which now allows me to say, well, if 1 equals 25 and 1 equals 7. Therefore, I can say that the measure of angle 7 is equal to 25 degrees as well by transitive property of equality now. So do you see how we got to match, right? I've got an equal sign, so I talk about equality, whereas up here, I had a congruent symbol, so I talked about congruency. We always got to match our symbols, okay? And we're done with the problem. They asked us to prove that 7 is 25 degrees. We proved 7 is 25 degrees. We are done. Let's keep going. Our next one is the converse of the alternate exterior angle theorem, okay? And when we are talking about the converse of the alternate exterior angles theorem, we're always going to start off first by reading our statement. If a transversal intersects two parallel lines, then alternate exterior angles are congruent. So my given is, again, K is parallel to L because we're given two parallel lines, and I want to prove alternate exterior angles congruent. I'm liking 1 and 7. Prove angle 1 is congruent to angle 7. Guys, this proof is remarkably close to the first proof you did, okay? You're proving two things congruent. So we have our statement and our reason, and we're going to go ahead and get started. I want to choose a helper angle that's going to correspond with one angle and hopefully be vertical angles with another angle. I'm kind of liking angle 5. Let's use angle 5. Angle 4 or angle 5 would both be good angles for this. So my first step is to list my given, K parallel to L, by given. And my next two steps is to state how 5 is related to 1 and how 5 is related to 7. Well, angle 1 is congruent to angle 5 by the converse of the corresponding angles postulate. They are corresponding angles and our lines are parallel, so we can conclude they're congruent. And angle 5 is congruent to angle 7 by the vertical angles theorem because they're vertical angles. Well, now we've got 1 related to 5 and 5 related to 7, which means I can now relate 1 and 7 to each other. So I can now say that angle 1 is congruent to angle 7 by the transitive property. Property of congruence, right? Because we're dealing with congruent statements. And that's the end of the proof. We've done it. Not too bad. Things get a hair trickier when we're talking about consecutive angles and things being supplementary. Anytime we jump into the land of things being supplementary, we have to actually worry about switching in between our equality symbols and our equal symbols a lot, so the proof gets just a little bit more complicated. But let's take a look. If a transversal intersects two parallel lines, then consecutive exterior angles are supplementary. So my given is two parallel lines, K parallel to L, and my proof statement, consecutive exterior angles are supplementary. Well, let's pick a pair of consecutive exterior angles. I'm liking 1 and 8. So I'm going to prove that angle 1 is supplementary to angle 8. And to do this, I'm again going to look for a helper angle that is corresponding with one of my angles and has a good relationship with the other one. I like either 3 or 5 because if I were to choose angle 3, 1 and 3 are a linear pair, and we know that linear pairs add to 180, and 3 and 8 are corresponding angles, so we know they're congruent and therefore equal. So that gives us two good relationships. So I'm going to use angle 3. So statement and reason, as always. And we're going to start off, of course, by listing our givens. Then we're going to spend the two steps after that talking about how our helper angle relates to both of the two angles of interest. So I start off with my given, K parallel to L, that's reason is given. And the first relationship I'm going to look at is angle 1 and angle 3. Angle 1 and 3 are a linear pair, and by the definition of a linear pair. And if angle 1 and 3 are a linear pair, then that means that the measure of angle 1 plus the measure of angle 3 must equal 180 degrees. And that's by the linear pair theorem, which we proved in a couple lessons ago. Linear pair theorem. Well, now I want to talk about how 3 and 8 relate. Well, 3 and 8 are corresponding angles, so they're equal to each other. So 3 is congruent to 8 by the converse of the corresponding angles theorem. And if they're congruent to each other, it also means that they're equal to each other. So the measure of angle 3 equals the measure of angle 8 by the definition of congruence. And the reason I had to do this is we are about to flip in between. I need to somehow get this meshing with this, and we have to get our symbols in the same family. So I need to do that conversion step to make sure they're okay. Well, I've already established that 1 plus measure of angle 1 plus measure of angle 3 equals 180. Well, measure of angle 3 also equals measure of angle 8. So I can make a substitution here, right? I'm now able to say that the measure of angle 1 plus the measure of angle 8 must also be 180 by the substitution property of equality. Remember, never shorten substitution or subtraction, because otherwise they'll look like each other. Property of equality, which we're trying to prove that they're supplementary. That's what it means to be supplementary. We're able to now say that angle 1 is supplementary to angle 8 by the definition of supplementary. And we're done. We proved it. All right, guys. Our last proof is the consecutive interior angle theorem. And so let's take a look at this. If two lines in a transversal form supplementary consecutive interior angles, then the two lines are parallel. So my given is that I have supplementary consecutive interior angles. So let's pick some interior angles. I'm liking 3 and 5. So my given would be that angle 3 is supplementary to angle 5. And I want to prove the two lines are parallel. Prove K is parallel to L. And again, guys, you only right now have one way to prove lines parallel to each other, and that's by the corresponding angle theorem, okay? And so if you can show that corresponding angles are congruent, then you can prove your lines parallel. So again, I want to choose a helper angle that's corresponding to one of my angles and then has a good relationship with the other one. I like either angle 1 or angle 8. I'm just going to choose angle 8 because I feel like it. And I like those angles because they're a linear pair with one of my given angles and they're corresponding to the other. So angle 8 is a linear pair with 5 and it corresponds to angle 3. So if I can get to the point where I can show that angle 3 is congruent to angle 8, then I have proven my lines parallel. So that's my goal. So let's go ahead and get started with the proof. We've got our statement and reason. Statement, reason. And we always start off by listing our givens. We would say that angle 3 is supplementary to angle 5 because that's given. And my next step, I'm going to talk about how I'm going to interpret this. What does it mean to be supplementary to 5? Well, it means that they must add to 180. So the measure of angle 3 plus the measure of angle 5 must equal 180 degrees. And that's just by the definition of supplementary. Now my next step is I want to talk about my helper angle, and I want to talk about my helper angle with relation to the thing I can talk about. I can go ahead and discuss how 5 and 8 relate to each other because they're a linear pair and that doesn't rely on the lines being parallel. I currently can't say anything about 8 and 3 because I don't know that K is parallel to L. I can't say anything about the relationship between 3 and 8 because they're in different clusters. So my third step, I'm going to say that the measure of angle 5, oh no, I can't do that. I have to state that they're a linear pair first, guys. So I will say that angle 5 is a linear pair with angle 8, and that's by the definition of a linear pair. So I'm now going to interpret that in my next line. That means that the measure of angle 5 plus the measure of angle 8 must be 180 degrees by the linear pair theorem. Okay. Well, now we've done a really great thing where we've managed to prove two statements equal to the same number which means now I can set them equal to each other. So now I can say that the measure of angle 3 plus the measure of angle 5 is equal to the measure of angle 5 plus the measure of angle 8, all by, guess what? The transitive property, which is my favorite property, guys. I love the transitive property. Transitive property of equality, because we're dealing with equal signs. Well, if you look, we've got measure of angle 5 in both statements, which means we can subtract it off. So now I have that the measure of angle 3 is equal to the measure of angle 8 by subtraction. Subtraction, property of equality. Well, if they're equal to each other, then we can say that they're congruent to each other by the definition of congruent. And guys, remember up here at our original plan, we said that if we could show that corresponding angles are congruent, that proves my lines parallel by the corresponding angles theorem. So we just showed that 3 and 8 are congruent and they are corresponding angles. So that allows me to prove that K is parallel to L by the corresponding angle postulate. And we're done. Yay! All right, guys, so your practice is going to prove some more of these theorems, okay? I'll tell you guys, these you can easily model after some of the other theorems we've done. So if you want to prove the consecutive exterior angle theorem, I recommend modeling it after the consecutive interior angle theorem. They're pretty much the same proof, just with different angles, okay? If you want to prove the alternate exterior angle theorem, go back and model on the alternate interior angle theorem. They're very, very similar. All right, guys, well, that's the end of the notes. Be sure to double check your practice assignment against the key before turning it in. Good luck with the knowledge check. Thank you.